Hi, today we're going to be going over how to set up your own test cases in EWS for CS225. So I'll first have you navigate to your EWS SSH. So this is what I've done here, and you know it's worked after you see this SSH and then the SSH target here. So I want you to open up your folder. So navigate to the CS225 folder that you have, and then go to any MP. For this one, we shall be working with MP list because I know that's a pretty tough MP, so we'll be choosing that as our example. So here for MP list, we can open it up. It may take a little bit of time initializing and may ask us for a password again, of which we shall type it real quick. Okay, now that you've loaded, you should see something like akin to this. It has your MP up here because we opened up the specific MP folder, right? And then you usually will see something like a CS225 folder here that has all the stuff that is the same across all labs and MPs. And you have like a test folder here that contains a bunch of images you're testing against, maybe some other stuff as well. And then your actual files you'll be working with usually in the home directory of your current directory. All right. So in order to make your own test cases, what you want to do is let's put them inside your test folder. Okay, we're going to right click the test, press new file to open up a new file, and we're going to name it anything.cpp. Okay, it could be, for example, my test.cpp. And I usually like to say my test because that differentiates the test file, so you know this is the one you add. Now, you don't have to be worried about this affecting anything on GitHub because there's this U symbol here. The U symbol means that GitHub has not currently tracked the file, and so it is unadded. In order to add a file, you usually have to do git add and then the name of the file. But because we do git add -u, the -u omits any file that is currently unadded. So for example, you see this U here or this U here, it does not add those files to the actual GitHub. So if you push the GitHub, your test will not appear. And that is okay because we only want to use them to test for our current code locally. So once you've opened up mytest.cpp, I usually like to start with adding a bunch of things that we will need. So please open up one of your tests, part 1 or part 2, other work that we've made for you. You can copy everything here because usually you'll use all, if not almost everything here in your test to test for things. And we can copy them over and include them in our test.cpp. Make sure to press save, or you will have this sort of solid bullet point here to remind you that you have not saved. After we've saved, let's start by making our first test case. So we can go by typing test case, parentheses, and then curly braces. Inside the parentheses, we can name our test case. For example, let's pretend we want to test list insert front, and then maybe let's do size 0. Okay, and then we can add tags here, and I recommend adding tags because tags are very powerful in allowing you to run multiple tests at the same time by specifying arguments when you run the test case. So here we will add a tag called mine that specifies that this test case is one of the test cases that I've created, such that when I run the command on terminal, I can run this test case and run all test cases that also have the same tag. If you look in test part 1, these tests also have tag, although we've named them differently. So for example, you'll note that coincidentally, all tests in test part 1.cpp have this tag part equals 1. That means that we're able to specify to run all test cases in this for part 1 just by specifying this tag. So let me make test for you, and we shall practice with just the test part 1. We can do /test, the name of our executable, and then we can put in an argument like part equals 1. Press enter, and you should see that if you've completed the assignment correctly for all part 1 problems, then you should see that all tests have passed here. So that is how we're able to specify tags. Now, if you want to specify just one test to run, we can do /test and the name of the test, list insert front size, for example. Enter, and you should see that we ran this function here and that it turned out to be correct. Okay. Now, one more thing is, let's say we wanted to run anything, any test that had insert in it, any substring insert. And for example, here, right, there's a substring insert here. It'll run this test case. It'll run this test case. Same thing here, right? And we should see there seems to only be 3 test cases that have this insert in the name of the test name. You can press enter and should see there's 3 assertions and 3 test cases. So we've currently ran the 3 test cases with the substring insert in them. And these asterisks here, we refer to them as wildcards, and you can think of them as we don't care what gets inputted in this wildcard. And so this wildcard at the end of this string would mean that we don't care what comes after the T after insert. And then the one before it would also specify we don't care what comes before the I in insert. And so this is a very powerful way of also testing multiple test cases at the same time. And this also goes to show how important it is to name your test cases well. And to name it with maybe the thing that you're testing so that it makes sense and you're able to leverage this when you're testing. So let's make our own test case here. As you see, this test case here is test for the general case, but what happens if size is 0, right? We want to make sure size 0 works, or size 1 works, and size 2 works, right? Just to make sure we're setting head and tail correctly. This tests for all of them at once, and so it's very hard to sort of know which test case, which specific edge case we're failing. And so we're going to be leveraging multiple test cases in order to help us find out what our problem is. So here, let us first write our first test case, and we've included list.age as well as any other things that we need to use, so we don't have to worry about that. We can specify a list by doing this. A list is templated, so we will use an int because it's easier for us to think about lists in terms of int rather than, say, a PNG, for example. That'd be a very big list. Let us try and make a test case for pushing back nothing, so we don't have to add anything. And we want to require that the size of the list equals 0, right? That makes sense, right? If we didn't push anything back or insert anything front, right? Then the list size should be 0. And so let's make another test case while we're at it. Okay. Test case like insert front size is 1 maybe. And what we're able to do is list.insert front, maybe let's say 1, right? So we should see in this list that if we print it out, there should be one thing in there, and that being the value 1. And if you look at some of your test cases, you're able to actually compare the contents of the list here, specifically using string stream as a function we provide to you in lists given. So let us use that to our advantage here. We will also, not only do we want to make sure size is correct, we want to actually make sure the contents are correct. So let us add that functionality real quick. List.print s, we'll print it to the string stream. And we can add multiple require statements, and they will all run for that test case. The test case does not pass unless all require statements are true. So here we want to get the string stream string and make sure it equals nothing, right? And note here, we're comparing strings, so we must make sure that they are equal. This, without the space, will not be equal due to how we print a list. So you want to make sure you're following that. If you don't know, you can check examples here to see, probably what makes sense and infer from there. We will do the same here, but instead of a, let me add string stream, string, oopsies, string s, list.print s, and then we will require that s.str, the string s, will equal 1, right? Which which makes sense because there's only one thing in there, that being 1. If I were to change this to 3, for example, I would change the 1 to a 3. And so we'll run this test case to make sure our list front works for size 0 and 1. Now, before we run our test case, and make sure you save. If you don't save and you make, your changes will not propagate. We want to run all of my new test cases, and so we'll be using mine. And as you can see, there are 2 test cases so far with the tag mine. So just inferring from that, we know that if we run /test mine, there's going to be 2 test cases that run, and then 4 assertions, right? Because there's 4 required. So that's where the idea there. So we can do test mine enter. Oh, sorry, I forgot to do test clear /test mine enter, and we have 1 failed. Let us see why that failed. So let's go to size 1. Require list.size equals 0. As you can see, this is supposedly false, right? Because 0, there should be at least 1 thing in the list. So list.size should be 1. So here we will change it. We will save it again. And as you can see, right, it will actually tell you if it failed. And we saw that, 2 assertions passed, right? And then 1 of test case passed, right? And it didn't run this line because this test case passed. So you're able to also leverage the order in which they do test cases in order to make sure that you don't get a seg fault, for example. So let's make test again. Right? Test mine, as you can see, it is as what we have mentioned before, that there's 2 test cases that ran and 4 assertions total. And so sometimes you might see something like 200,000 assertions. That's mostly because we might have asserted every single pixel in your program, so then it's the entire size of that image, right? So that's why you get some assertions that are very big, but not a lot of test cases, for example, right? That's one example. So this is how you would write tests and how we write tests inside our CPP files. And if you're ever unsure of how to make a test for your MP or your lab, you can feel free to refer to one of the test files that we've given you to draw inspiration from and to see syntax. But I highly recommend you make your own test files to run your own tests, both so you can see what test cases may be wrong, and that way you can debug faster by knowing what is wrong, as well as we don't want you to be changing the test files we give you in the event that you might accidentally push those changes and cause undue stress if you accidentally change something that now the test case doesn't work, but your code might work, right? So you don't want those problems to hinder you from completing the MP. So I urge you to make your own test cases and to test thoroughly with a debugger. Thank you.